Hello my viewers, welcome back to another Hex Maniac Advance tutorial. This tutorial is guest number 2, Inserting Thumb Code. This tutorial centers around using code routines from places like PokéCommunity. It does not cover making your own. Regardless, I'll explain what exactly I mean by thumb code. Then I'll demonstrate inserting a couple of things into a ROM that are all segments of thumb code, such as the No Guard ability, modern Destiny Knot mechanics that relate to breeding, and a method that lets trainer Pokemon have EV spreads. And we'll close off with a couple of pointers to help rectify any problems you may have with these segments of thumb code. I hope you enjoyed the video. So what I have in front of me is a ROM that has the trainers with Eevee's thumb routine. Neither the ROM data nor the table format are present by default. It basically creates a database filled with competitive builds trainer Pokemon can have, and lots of trainers in this difficulty hack make use of this to make the player have a harder time winning the game. When you insert thumb code over and over again, you can import a lot of modern features into these very old games, thanks to the decades of contribution by Pokemon fans all across PokéCommunity, Whack-A-Hack, etc. However, because I'm going to be showing you the process of importing code from someone else, it is very important to actually credit the person that provided the code in the first place, as they took the time that they need to actually make the code and make sure that it actually works. And thus, it wouldn't be right to plagiarize at their expense. When you release your ROM hack, you can provide a credits section in the forum thread, or you could have a custom credits scene. It's up to you, as long as you give credit where credit's due. That aside, I've been talking a lot about thumb code, without really explaining what I mean by that. Let me rectify that real quick. So, thumb code makes up a vast majority of the ROM's game mechanics. All instructions or thumb commands directly interact with the Game Boy Advance's processor and registers as opposed to the game itself in a way. It's a specific type of machine or assembly code, instead of languages like C++ or Python, where people write code that ends up getting compiled into machine code. If you know thumb code really well, you can practically do anything you want with it, at least within the limits of the hardware. However, you need to be careful as things could quickly go wrong if you made a mistake with your code segments. However, for this tutorial, that won't really be an issue. Here is an example of what thumb code looks like in Hex Maniac Advance. There are lots of commands with short names, lots of numbers with hashtags, lots of numbers with the letter R, which are registers, and lots of pointers and addresses. And the bytes that correspond to the instructions aren't too consistent. Switching gears, I'm now going to give a miniature crash course on how thumb code used to be inserted back in the day. Before Hex Maniac Advance was around, you would need a separate program to compile thumb code. There was one made by a well-known ROM hacker named HackMew. For example, here's this segment of thumb code that adds a blue and red color to stats that are affected by a Pokemon's nature. The thumb code here looks slightly different than what it would look like in HMA. What people used to do was copy all of the thumb code they found from the thread, including these directives up here, load up the thumb compiler, and paste everything into the text box. Notice that this particular compiler has section names, comments, and instructions color-coded. To compile, click Compile, then Output to bin or Insert into ROM. Then, you'd have to specify the name of the ROM, or open the .bin file in a different hex editor, and manually copy and paste the bytes. While HMA makes this process a bit more automatic, the places where you get the thumb routines from will assume that you're not doing things the new way, making things a bit more tricky. But we will work these things out in this tutorial. As another warning, editing thumb code related to core game mechanics can lead to your ROM hacks becoming obsolete because of excessive crashing, so it's of the utmost importance to back up your ROM often. To do this, click File and Export Backup. Fill in your most recent change to your ROM in this text box here, click OK and your backup will be made for you. In the same folder as your ROM, there will be a backups folder that contains a copy of your ROM and metadata file. It's important to back up both your GBA file and TOML file. Let's start paying a visit to PokéCommunity.com. For this tutorial, I'm going to get a lot of my things from the site called PokéCommunity. There are several threads full of things you can implement. I'll start by Googling the Move Resource thread. Use this search term, cite PokéCommunity.com, to ensure that the top result is the correct page. I'm just going to open that in a new tab, and there's also this ability resource thread that luckily showed up here. I'm also going to open this in a new tab. Lastly, I'm going to do a Google search of the ASM resource thread, which contains miscellaneous things you can implement via inserting thumb code. I'm sure there are other websites and threads you could find for resources, so you may want to do some exploring. For the move resource thread, there is a section full of new move effects, and another section with updated move effects for previous generation moves. In the ability resource thread, you can find thumb code for a handful of abilities, though some of them are exclusive to Fire Red or Emerald. Further down the page, you can find implementations for Generation 3 abilities that have updated effects. There's also the ASM resource thread where you can find miscellaneous features that you can add to your ROM. There are different sections for different Pokemon games, though unfortunately Fire Red 1.0 has the most amount of available implementations, just because historically most of the ROM hackers have hacked Fire Red 1.0 over other ROMs. So if there's something you want to implement but is not supported in your ROM, there aren't really a lot of things you could do in order to actually get the feature you want, which can be pretty frustrating. I've experienced it firsthand. I'm now going to begin the process of implementing the No Guard ability, though the preliminary work involves actually making a No Guard ability slot in the ability table, which is what I'll do right now. So I repoint a duplicate description for the airlock ability, supply the name No Guard to one of the duplicate airlock slots, and adjusted the description. I also give Poochyena, one of the Pokemon in my party at the time, the No Guard ability over Runaway. So now I'm going to go to the PokéCommunity thread, which I'll link in the description, and you should be able to clearly see a segment of code that corresponds to the name of the ability and what type of ROM you're editing. So here's what the thumb instructions in a segment of thumb code typically look like. On PokéCommunity, you can see that the code is divided in a lot of sections. All I need to copy right now are the actual thumb instructions, not any of the lines that start with periods. I also leave alone the comment at the end that tells me to place a couple of bytes at a particular address. This is usually what you're going to see in a majority of thumb routines on PokéCommunity. There will be different bits of code for different things to implement, but the process should be the same. So back in the ROM, I go to another address in the free space, and then I hover over Tools and click Toggle Code Tool. Make sure that in the drop-down you see the word thumb. Now once you have that settled, you can just paste the code that you just copied, and HMA compiles it instantaneously. Let me get rid of this align to directive, we don't really need it. Now you can double check to make sure that you're not missing lines of code that you actually need, or any relevant RAM/ROM addresses that need to be loaded. Also, since PokéCommunity expects abilities to be in specific slots, the ID of, say, No Guard may be different in HMA. As for abilities, and this can apply to other instances where some things may be hard-coded, look at the names of the sections before clicking out of the whole thing. Look for the lines of code that check for, in this case, the user's ability or the target's ability. Based on what I found, the code checks for ID number 0x64, and I'm going to change that. I'm navigating back to the abilities table, and I will click on the entry for No Guard. If you see up top, this ROM has No Guard's ID as 78. With that information, I'm going to go back to where the thumb code is, and I'll have to select all of the bytes again. Now when I return to the code tool, you might freak out from the multitude of changes. While it sucks that the labeled sections are gone upon recompilation, all of the actual thumb instructions are there. As previously stated, these comp R0100 lines basically check for the No Guard ability based on its intended ID of 100. I'm just going to go into the text full of code and replace the 100 with 78, which is my ID for No Guard in this ROM hack. Going back to the PokéCommunity page, you'll almost always see directions like this, where you insert 8 bytes at a particular address in order for the compiled code to work. A trick to mitigate troubleshooting is to copy this address here and paste it into the Go To menu instead of typing it. Before editing the bytes, you want to make sure that the existing bytes in your ROM hack are the same as in the corresponding vanilla ROM. Since the directions wanted me to replace 10 bytes, I select 10 bytes starting from the given address and check to see if all of them match. And in my case, these shown bytes were in the hacked ROM in my footage, indicating a 100% match. If there is no 100% match here, then you probably shouldn't use this thumb routine on your ROM, as it could seriously break something else. That aside, I need to remind myself what bytes to insert. Here's a chunk of 4 bytes here, which most things of thumb code will have you insert, maybe with some slight variations here and there. Then you'll see XX, XX, XX08, which is pretty much a pointer to the thumb code. Well, kinda. And then the last two 00 bytes, which I neglected. Copy the first 4 bytes, then paste at the specified address that you should have already went to in HMA. Don't click save yet. You want to keep track of your gradual changes. Now the next and possibly last 4 bytes that you have to insert have to reference the area of the ASM code that you pasted in. So I'm going to navigate back to where it is in byte form and take note of the address. Back in the other place, I'm going to start typing a pointer to the address. But the important thing is to put a +1 before closing the pointer with the greater than sign. The reason why adding a +1 after the address of the thumb code is required is because this will ensure that the Game Boy Advance will continue running thumb code when you jump from the vanilla game code to other code that's in a different place in the ROM. If you don't put a +1, the game will crash 100% of the time when trying to run the new code. In general, if you want to quote-unquote repoint thumb code so that you can include new game mechanics, these commands shown over here are one way you can do that. I still didn't end up putting 2 00 bytes afterwards, but you'll see that it didn't actually matter. But depending on the code, there are cases where it may matter. Anyways, we can save changes and test it in game. The following footage will be sped up. If you have epilepsy, please skip to this timestamp. So to test if the thing actually worked, I started using Iron Tail over and over again in battle, and I used save states as in this generation. The outcome of a turn is not predetermined immediately in regular battles, and I went through this at least 60 times. To my amazement, Iron Tail did not miss once. In case you don't believe me, if you look closely at the footage, you can see that some of the outcomes are different, including a very rare critical hit and some damage ranges, not resulting in a one-hit KO. Although save state timing may impact the odds, on screen is the theoretical probability of Iron Tail landing 60 times in a row without any accuracy modifiers. Because it's minuscule, we can infer that the no guard ability is actually working here. And you can also see in the summary screen that Iron Tail has a 75% accuracy, not 100. So just to recap for the viewers who skipped some footage, I used Iron Tail 60 times against a Wormpole, and I didn't miss a single time. Although using save states could have impacted the results, the probability of missing 0 times was tiny, so it's safe to assume that the ability blocked accuracy checks successfully. Alright, that was a good exercise. Let's do some more. Let's now overhaul breeding mechanics by implementing a very nifty item. So here I am at the PokéCommunity thread, which I'll also link in the description, that has more thumb code related to changing how IV inheriting works. So compared to the previous thread, this thread is a little bit less straightforward. As you implement more complicated thumb routines, or thumb routines that are more flexible, the instructions and other things are going to become more elaborate, and you might see things in some forum posts that don't exist in others. For instance, some threads have precompiled bytes that correspond to the thumb code, and you can just copy-paste those bytes instead of compiling the code. And I mean, hey, if it's there, you might as well use it. Though there are cases where you may want to edit the thumb code in HMA if you need to make a couple of changes here and there for one reason or another. There are also comments made by the creator of the post that outline a couple of things, mainly changing 2 numbers to match the item ID of the Destiny Knot in your ROM hack. If I dig deeper in the forum post, you can see a couple of comments in the thumb code itself that show you where to change a couple of numbers. Now what I'm going to do is create a new Destiny Knot item in my ROM hack. So I open the items table, scroll down to an empty item slot, and fill in the necessary information to make the Destiny Knot item minus the sprite, which I don't really care about for this tutorial. Also making sure to repoint duplicate description pointers. Also making sure that it's in the item pocket and the type is bag menu. For more information about the items table, check out the tutorial that I'll have in a card. I'm also going to change the index field so it's more consistent with the other items. Also, I kinda messed up here. I recorded all of this footage while editing Emerald while forgetting that this is for Fire Red only. However, for the item portion only, the process will be the same, regardless of version. Moving forward, I'm now about to insert the code. So I'm back at the thread and there are a couple of options. I can copy and paste the compiled bytes, or I can copy the uncompiled code. I chose the latter, so I'm going to select all of the code except the align to at the bottom and everything before the main section, because those are instructions for the thumb compiler. Now in Fire Red, I'm going to select an address in free space. The address must be a number that's divisible by 4. None of these 3 selected offsets are going to work because the bytes will be interpreted as different thumb code by the game, which can cause all sorts of problems that were unintended. To ensure that your inserted code works as intended, your address number must end in either 0, 4, 8, or C, as those are numbers that are divisible by 4. Next, I'm once again going to activate the code tool, making sure that the code type is set to thumb, and then I can paste the code. As previously mentioned in the PokéCommunity post, there are a couple of things I will need to change. Fortunately, the comments carried over, and I can see the 2 lines of code where I can change the number in the hashtag from 1 to the index of the Destiny Knot item that we implemented. Also in HMA, the numbers in the hashtags can be either hexadecimal with 0x or decimal, so there's less of a need to convert. You might have caught this detail in the PokéCommunity post. Some of the registers, like R1, R2, R3, etc., have special names, and HMA recognizes those names, and thus will compile them correctly. Here are the ones I'm talking about. So I clicked out of the thumb code and I selected all the bytes again. And now the thumb code looks a little bit different. When re-examining the code, be on the lookout for this specific thumb instruction. NOP. Usually when you see this, it means that something went wrong when compiling the code from PokéCommunity. Don't freak out, try to find ways to fix the problem. Luckily, this one provided a pre-compiled version. We can use this to compare the bytes of the 2 different compilations. So I'm going to copy these bytes and paste them to another address in free space. First of all, right off the bat, I got a little suspicious when I found out that the bytes are different for what's supposed to be the same thumb code. The thumb code that HMA compiled is 8 bytes longer than the pre-compiled version. We'll figure out why later. Anyways, back to the NOP. It was found right underneath the move R1 140 command. If you find the same command in the pre-compiled version, what's actually underneath is multiply R0 R1, which HMA didn't pick up for some reason. What I'll do now is copy it, reselect the bytes of the other thumb code segment, and paste it, overwriting the NOP instruction. The hex bytes update in real time. Now if I look at the thumb instructions on the thread itself, you'll notice that the line below move R1 140 has the same multiply command but with a slight difference, which HMA believed was invalid. So for my final judgment on which one to use if you're given both the precompiled bytes and the regular thumb routine, try using both and see which one works best for you for whatever you're implementing. But keep in mind that if you need to make changes, make them in HMA as needed. The other discrepancy I noticed is related to why the number of bytes is different for both things. Is that this particular RAM address is used twice when HMA compiled the code, while the precompiled version only used it once. To confirm this, I input the RAM address in its reversed form because the GBA reads most numbers with their bytes reversed, and you can see the 4-byte sequence stand out in white text a different number of times for what should be the same code. I also noticed extra 00 bytes that come in pairs. They show up from HMA's compilation, but not the precompiled version, when I type 200 bytes in the find menu. Thus, the extra padding and the reuse of one RAM address explain why one compilation has more bytes than the other, though I'm pretty sure that, at least functionally, they're both the same. To generalize, the older thumb compilers put all their pointers to the ROM and RAM at the very end of the thumb code segment, while in HMA's case, the words are implemented whenever they are first needed, so that's one source of potential discrepancies. So here are a few takeaways from all this. If you ever find that HMIA compiles thumb code incorrectly, file a bug report in our Discord server, which will be linked in the description. Before testing the code in game, take a look at it after clicking off and reselecting the bytes. It's helpful to keep an eye out for any potential signs of things looking suspicious using your intuition. Try to resolve those suspicions by correcting mistakes in the code. You can use precompiled code as a reference, and or doing what I did with figuring out why the number of bytes varied. If you're uneasy with these variations, you can test all of them in game once we're done finishing the implementation and see which ones work or don't work. It's all trial and error. Remember to make backups along the way. Sorry for my tangent after pasting that thumb code. There was just a lot that I needed to say. Anyways, the next thing to do is to go to the specified address and overwrite a couple of bytes. In my ROM, I made it to the specified address, and now I'm going to select the first 4 bytes that I was instructed to insert. Afterwards, I copy them and I paste them into address 460F8. And now for the pointer plus 1 bit. I have a couple of options for the feature I want to implement. I can go with the address of the thumb code that I compiled at first, which in my case is 7740s. And it would correspond to these 208 bytes over here, with the slightly unorthodox placements of the words. Or I can go with 770100, which corresponds to the precompiled code I pasted in earlier, aka these bytes. As for which of these options to select, you can experiment by trying all of them, well, one at a time, and see which ones work and which ones don't. No matter the scenario, you still need a +1 at the end of the pointer. This way, you can prevent the game from crashing. What I'm going to stick with for now is the first option. For the sake of this video's length, in terms of testing, I will just cut to the chase and show you the end result as opposed to the whole setup. Unfortunately, no matter what I did, the thing just wouldn't work. Every single time after I get the message saying that I received the egg, the game will always repeat a couple of custom thumb commands, which prevents generating all of the stats of the baby Pokemon. The specific problem is that R14 is not supposed to stay at that particular address indefinitely. I'm thinking the reason why we're getting the infinite loop is because there is some vanilla code that's being called by the thumb code, and it's putting a lot of data into register 14. So yeah, you may run into some dead ends by some programming errors by other people. This may not be a guarantee, but what you could do is contact the creator of whatever thumb routine you're inserting and let them know that there are glitches. Or you could bring it up on a ROM hacking Discord or forum thread, and another ROM hacker might be able to give you the steps you need to fix the code. At the very least, however, you're still going to have another tool in your toolbox while you're ROM hacking.